You were there right in the previous class for this.
So I'm not able to hear you. 1 minute.
You were present in the last class, right? In this, in which we have discussed about the activation energy and all, and this graph.
One class I didn't join. I guess the first class I was not there, or some no second class because
Okay. So let's start with a new topic, that is basically Arrhenius equation. And today I will not be able to teach you for 1.5 an hour because I'm not well today.
so you're talking about the extra class.
No. I was saying that I'm not well today, so I will not be able to take class for 1.5 an hour till 10:30 p.m.
Okay, sir.
Okay, thank you. So let's start your Arrhenius equation, and Arrhenius has given an equation that is k equals to a into e raised to the power minus ea upon rt. Now I'm going to tell you what is this k. K is basically your rate constant. This is rate constant. Another a, this is your Arrhenius constant. Arrhenius constant. And ea is your activation energy. Basically, this energy required in a reaction to convert into product, activation energy. And R is your gas constant, ideal gas constant, and T is your temperature. T is your temperature. Now, I'm going to derive a formula from this Arrhenius equation, taking anti-log both sides. Taking anti-log both sides. So you can see that if I'm gonna take anti-log both sides, there will be ln k, and according to the rule of the log, this will come in. The power will be written like this: e, whatever is the power will come here, minus e upon rt plus ln a will be there. So I'm going to plot a graph with the help of this equation, and the graph is in between ln a and 1 by t. So you can see that I'm going to compare with this is y and this is 1 by t, which is x, and they are directly proportional to each other. That's why the graph will be a straight line, but there is a negative sign that shows the graph will be downward like this, and this part will be this intercept, which is ln a, and also this is the slope is basically the slope is the slope will be equal to, wait a minute, the graph is in between ln k versus 1 by t. Slope is basically minus ea upon rt. All I want to say is that the graph is based on a straight line equation, that is y is equal to mx plus c, in which c is the intercept, m is the slope. So whatever is the number or anything multiplied in x is the slope. That's why I wrote this slope will be equal to ea upon r. This is x and this is slope. So this is your x and this e minus e upon r is your slope. So there is this graph according to this equation. Please do write. Please do let me know when you are done. Am I audible to you?
Yes, sir.
So in the last class we had completed the equation as called Arrhenius equation. And from Arrhenius equation we I just derived a formula, that is taking antilog both sides, ln k will be equal to minus E upon RT plus ln k. And with the help of this equation, we can plot a graph between ln k versus 1 by t. You can see y is directly proportional to 1 by t, which is x. That means a straight line. And negative sign is there, that's why downward. Please do let me know when you are done. Are you done with this, Mariam?
Sorry, sir.
Are you done with this?
Yes.
Amen.
Yes, sir. Done.
Now I'm gonna derive the formula again from this. As you can see that we have ln k equals to minus ln k equals to minus EA upon RT plus ln. Now I'm gonna take at temperature T1, the rate constant is K1, and at temperature T2, the rate constant is K. So here you can see I'm gonna just modify it, and it will be basically ln K1 will be equal to minus EA RT1 plus ln. And here you can see ln K2 will be equal to minus E upon RT2 plus ln. And this is your equation number 1. And this is your equation number 2. Now what you need to do is equation 1 minus equation. So left will be subtracted in left. ln K2 minus ln K1 will be equal to, first I'm going to write the second equation, EA upon RT2 and then plus ln. Then we are going to put negative sign here, and you can see that since we are subtracting 1, so negative will be positive, EA upon RT1, and you can see that positive is here and negative is here. So negative, positive, negative will be there. It will be in negative. ln A and ln A will be cancelled. ln K2 upon ln K2 minus ln K1 can be written as ln K2 upon K1 will be equal to, I'm just going to write it first, EA upon RT1 minus EA of RT. So please do write it up to this. Then I'll do the rest in the next slide. Rim.
Yes, sir.
So this is Arrhenius equation that we just modified and deriving a formula. Please do it and let me know when you are done with this. Are you done with this?
Done, sir.
Okay. Now you can see that this ln upon k1 is as it is, and I'm going to take e upon r common. Then there will be 1 upon t1 minus 1 upon t2, and again I'm going to take LCM of t1 t2. And this will be t1 t2, and then t2 minus t, and this will be ln k2 upon k. If you are going to change ln into log, then 2.303 will be multiplied. It will be log k2 upon k1 will be equal to EA upon R into T2 minus T1 upon T1 T2, and we can also write log K2 upon K1 will be equal to EA upon 2.303 R, and then T2 minus T1 upon T1 T2. Please write it and let me know when you are done. Please do let me know when you are done with this. And are you done with this?
Yes, sir.
Okay. So it's very easy. Now I'm gonna start a new topic, that is effect of catalyst. You can see what is the effect of catalyst. So you know that it increases rate of reaction. So first of all, I'm gonna write a point and then I will explain. A catalyst is a substance which increases rate of reaction, reaction without undergoing any permanent chemical change. Itself. So basically, what does a catalyst do? Catalyst increases rate of reaction, and how does this takes place? I'm gonna explain. Just suppose this is T2KClO3, and if you are going to heat it, it will be broken, or it will take time to break or give the product like 2KCl plus 3CO, 3O. But if you are going to use catalyst like this MnO2, the reaction will be very fast. Actually, what happens with the help of catalyst, activation energy decreases, and when activation energy decreases, rate of reaction increases. The rate of reaction increases. So indirectly, rate of reaction increases. With the help of catalyst, activation energy decreases. That's why rate of reaction increases. I'm gonna explain this with the help of graph. First, write it and let me know in your comments. Nadia, why are you late?
Sir, I was actually in another class, that's why I got late.
So all of you today I'm not well, so I will not be able to take class till 10:30. Okay, most probably I will be ending this class about 10 p.m. Will that be okay with everyone? Thank you. Just let me know when you are done with this.
Done, sir.
Very good. Now see that I'm going to plot a graph that you have already seen in the previous class. This is a graph between potential energy and the reaction coordinate. And the graph is like this. Can anyone tell me, is this graph for exothermic or endothermic? Aman, what do you think, Aman? Is exothermic. Now you can see that this is reactant and this is your product. And I told you that this point is activated X, or we can call it intermediate. Intermediate. And the energy between reactant and intermediate is called activation energy. This path is basically path without catalyst, path without catalyst. And we can also say this activation energy without catalyst. But if you are going to use a catalyst, then the path will be like this. Path will be like this, and you can see the activation energy decreases. And the red color shows that path without with the catalyst. And you can see if the activation energy decreases, then the rate of reaction increases. Please do that. There are some points which is very important regarding this catalyst. A catalyst does not affect the equilibrium constant. If the reaction is at equilibrium, it will not affect of the reaction. In the presence of catalyst, activation energy of a reaction decreases, and hence ROR, that means rate of reaction, increases. Rate of reaction increases. Next, we can write a catalyst does not alter or any effect on Gibbs free energy. Please do write. Please do let me know when you are done with this. Are everyone done with this?
Yes, sir.
I'm gonna give you a question. Please do it. A reaction is second order with respect to a reactant. How is the rate of reaction affected? If the concentration of the reactant is doubled and the second is reduced to half. Please do this question. Please do let me know the answer. Very good, Nadia. Any other answer from any student? Aman, Rim, Mariam. Mariam, am I audible to you?
Yes, sir.
Should I explain? Or you
Yes,
can
sir.
do it? Okay, let's see. A reaction is second order with respect to a reactant. Just suppose there is a reaction R converting into product P. And if it is a second order reaction, rate will be equal to rate constant into the concentration of reactant raised to the power 2, and this 2 shows that it is second order reaction. Now see, this is your rate R, that is equal to K into R raised to the power 2, and the new rate R dash according to the question, you can see that the concentration of R is doubled now. Concentration of R is doubled now, so the new rate will be equal to K into concentration 2R whole square. Order of the reaction are same. The square of 2 is 4, so I can write 4K R square, and you can see this is KR square, this is KR square. So R dash will be 4 times of the initial rate of reaction. Please do write it. In the same way, you can go for the next second. According to the question, the new concentration is half of the initial. So R dash will be K into R by 2 whole square. And then this can be written 1 by 2 square, that means 1 by 4. So it will be 1 by 4 K into R square left. And you can see this is the value of initial rate of reaction. So R dash will be 1 by 4 times of the initial or cold rate of reaction. Is that clear, everyone? Mariam, Rem, and Aman. Everyone done with this? Can I change the slide? Mariam, Rim, are you done with this? Please do let me know.
Yes.
I'm gonna give you another question. In a pseudo first order reaction, first order hydrolysis of ester inverters. The following results were obtained. The following results were obtained. T in second and concentration of ester is given as mole per liter. This is T in second. T slash second means time in second is given. Now you can see that T equals to 0. It has a concentration 0.5555, and at T equals to 30 seconds, it is 0.17, and at T equals to 60 seconds. Now the concentration is, wait a minute. This is 0.31 first and then 0.17, and at T equals to 90, 0.085. So we need to calculate the average rate of reaction. Average rate of reaction between time interval 30 to 60 seconds. Please do this question. Let me know when you are done with this. And then are you done with this? Madia, Mariam, Vim, Very good. Very good. We have 4.6 into 10 raised to the power minus 3, right? It's right answer. And to see, it's very easy. We need to calculate the rate of reaction. What we need to do, average it between 30 to 60 seconds. So what is the concentration here? It is 0.17. At 30 seconds, it is 0.31 divided by final time in yield time. So it will be equal to 0.14 upon 30, which will be equal to 4.67 into 10 raised to the power minus 3 mole per liter per second. So this is it for today. I'll see you on Wednesday. Sorry for the inconvenience. I'm not